Hello students. So in this video we will learn about the part element of computational techniques, or basically numerical methods. It is a part of mathematical physics. Okay. Under this topic of numerical method there are four parts basically. Solution of equations, integration, solution of differential equation and interpolation. So for the very first video, we will go for the solution of equations. In general form, we have two types of equations. Either it's a polynomial equation or transcendental equation. What is a polynomial equation? Polynomial equation is basically have finite number of terms. Okay, like this is a polynomial equation, this one is also a polynomial equation, and this series here, this n is finite. Okay, the number of terms is finite. Transcendental equations are the one which can have infinite number of terms. For example, the sin x is equal to x. It's a transcendental equation because it can have infinite number of terms. Like expansion of sign can lead to infinite number of terms. Similarly, e raised to power x is equal to x is also a transcendental equation. So the first thing we will study about how roots of an equation is found, okay, using the following methods. So in our lower classes, as in during school time, we used to use simple formula for finding out the roots, like factorize, or using the formula minus b plus minus under root b square minus 4ac upon 2a. These are the basic formula which we use to find root, and it is called the analytical method. But what we will do under this thing is we go for the numerical methods. Numerical methods are practically quite useful, okay, and one must study numerical methods. Yeah, these are important. So moving forward, how do we define these numerical methods? Like, what do we know about these numerical methods? These numerical methods are approximate methods. Like, these are not going to give you the exact value, but these gives you the approximate value, and the accuracy of calculation is improved by iterative or repetitive technique. As example, we can see in our physics experiment, we perform an experiment multiple times, like to get many of the reading, and then we go out for their mean, like what is the mean result. Similarly, in the numerical methods, we go for the policy of repetition of steps, like we do it more times to get a better result. Okay, so the first method which we will be discussing is the bisection method. See, as the name suggests, bisection method, bi means two. So in this method we basically go for two numbers. Let there be any two random numbers. Yeah, so let's read out what is exactly in this method. Let fx is equal to 0 is an equation. Okay, in bisection method we choose two initial values of x, which basically we guess two initial values of x. Let these are x0 and x1. Okay, x0 and x1 are two random values of x which we are guessing, such that fx0 into fx is negative. Okay, so what does it mean? The product of fx and fx0 should be negative. If this thing is not happening, for example, there is a function fx, okay, and we take out two random variables, like the random variable 1 and 5. So if the value of f1 and f5 on multiplying is not negative, we cannot take these two. We need to check out some other guesses. Okay, so for example, here is a graph. Okay, in this graph we plotted a function signifying y-axis by fx, and x-axis is basically at x. Now here is a point r which is the root. Okay, so in bisection method what we do is consider two random points, random variable. So here is x0, x0, and here is x1. Okay, so if fx0 or fx0 into fx is negative, then the first root we get is x2 is equal to x0 plus x1 by 2, or which we can call at root after first calculation or root after first iteration. How this came is basically, for example, if I say like the very first thing which we have considered here is the condition, that is fx0 into fx should be negative. This negative sign or the negative product ensure the presence of root in between that range. Okay, for example, if the sum is positive only, okay, for example, if we take this point and this point, okay, and whenever we calculate the fx like of this point into this point, whatever the result it will come, it will always be positive. Hence root is not existing at this side. If we take these 2 points, okay, if we multiply fx of these 2 points also, it will also be positive only, like minus of fx, like the first one will be minus, the second one will be minus, and whenever we multiply it we get a minus result. So if the product is negative, which means one of the value is positive, one of the value is negative, and there in between lies a 0. Hence we take this product as negative, okay, and we take x2, which is the middle point of x0 and x1, as its mean. Okay, now it is simply the mean after the first iteration. When we move forward, we take x2 as a point, we calculate fx2. Okay, now if fx2 is positive, okay, then what do? We calculate the product fx2 into fx1 and fx2 into fx0. If fx2 into fx1 is negative, okay, then what do? We find that from this particular thing that the next mean lies, or the mean, the root lies between x1 and x2. Okay, here as I've mentioned, like let fx2 into fx1 is negative, therefore the root lies between x1 and x2. So what we take, like we take x3 is equal to x1 plus x2 by 2, and it is the root after second iteration. And if like the fx2 into fx1 is positive, we get to know that the root is not between x1 and x2, the root is between x2 and x0. Okay, see, after every iteration we are moving towards the mean, okay, towards the actual mean of the thing, and every repetitive iteration narrows down the border, like narrows the range of the mean. That is what bisection method is about. It slowly reaches towards the mean by, tining out the interval. Now we move forward, like if fx3 and fx2 product is positive, so the root won't be lying between x3 and x2, correct? The root will lie between x3 and x1. Okay, so we get x4 is equal to x1 plus x3 by 2, and it is the root after third iteration. See, bisection method is pretty simple. You just take randomly random two numbers. You put the value, take the middle point, you check it like by finding out the value of the middle point, and you check it by multiplying it with x0 and x1. Whatever the result is negative, you narrow down the interval again. You follow the same procedure. Take two numbers. If the product is negative, find the middle point. Check out whose product is negative with the middle number. Then again narrow down the interval and go and find out the further solution. Here is an example. Find the solution of equation e raised to power minus x is equal to 0 by bisection method. Fx is equal to e raised to power minus x, correct? We take x0 is equal to 0 and x1 is equal to 1. The random two numbers which we are taking for this calculation is 0 and 1, okay? As initial guess. So f0 is 1 and f1 is e raised to power minus 1 is equal to 1 upon e minus 1, that is 0.37 minus 1, that is minus 0.63. So since their product is negative, like a positive number into a negative number is always negative, so what do we get? x2 is equal to x0 plus x1 upon 2, that is 0.5. okay, we now go towards narrowing down the interval. We take the value at f 0.5 and what we get here is 0.10653, which is a positive number. Okay, f0 was positive, f0.5 is negative, so the root cannot be found between f0.5 and f0. The root is between the interval f0 and f1 because it is positive and that is negative, and the product will be negative. So the root lies between 1 and 0.5. Again x3 is equal to 1 plus 0.5 upon 2, that is 0.75. f0.75 gives out a negative number. It is a negative number again, so the root will lie between 0.5 and 0.75 because f0.75 is negative, f1 is also negative, and when these two are negative, the root cannot lie in between them. The root lies between those two which have opposite sign, one positive, another negative. So we take x4 later on and do the further calculations. It's simple. At the fourth iteration, what the result we get is 0.5625. okay, and when we take out the actual graph of it, we get the value 0.567. So bisection method is leading us to a point where it is correct up to 2 decimal digits, and the third digit gets a little up and down. Okay, that's not a major problem, but still one should know how to perform bisection method. The next method which is important and which one should know is Newton-Raphson method. See, the difference between Newton-Raphson and bisection method is bisection method moves slowly towards the interval, like it narrows down half, but under bisection it moves quite slowly, it converges slowly, but under Newton-Raphson it converges quite swiftly, like up to a large interval. So in Newton-Raphson method, for root finding, we take a function fx is equal to 0, which is the given equation. Take one initial guess x0. Like in bisection method, we used to take two guesses, like guess two numbers, but in Newton-Raphson you just need to go for a single number. We find the tangent at it, okay, and x-axis at that tangent crosses the x-axis at x1. Here we can see, here is another picture. It's not quite clear, So I made it here. Yeah, it is a function. This curve is a function. Here is the point x0. We mark it on the curve. We make a tangent over here, a tangent crossing the point like x0 on the curve. So we mark this point as x1, the angle as theta. Okay. Now what do we know about the slope? Slope is like change in height upon change in the base. That is basically the tangent thing. So what we get here is tan theta is equal to f0 upon x0 minus x1. Okay, this point is x0, this point is x1. So tan theta is equal to f x0 upon x0 minus x1. Tan theta can also be written as df by dx, where x is equal to x0. Okay, basically that is the slope. That is how you define the slope of a function. Change in the function with respect to change in x, right? So this thing can be written as f dash x0. Okay, so we write it as f dash x0 is equal to fx upon x minus x0. Terms, what we get after final calculation is x1 is equal to x0 minus fx0 upon f dash x0. What do we see here? This x1 in the plot is closer to the root. Okay, so as we will continue this process of doing this thing, this further iteration, it will move close and close and closer towards the final root. Okay, so similarly x1 is equal to x0 minus fx0 upon f dash x0. x2 is equal to x1 minus fx1 upon f dash x1. x3 is equal to x2 minus fx2 upon f dash x2. And similarly, the main iteration formula is xn plus 1 is equal to xn minus fn upon f dash n. It is quite important, and people do get questions of it into various competitive exams, so one should know this base formula. This method does not work if the initial guess f dash x0 is 0. The most important thing about this method is that f dash x0 should not be 0. Like, if this gets 0, it stops. There is no further calculation. Like, if you have any number upon 0, that's infinite. Okay, so we move forward. Here was a question which came in net exam June 2019, that you need to find using the Newton-Raphson method, you need to find the second iteration, or like iteration formula. The function given was x is equal to 2 sin x. Change the term, fx is equal to x minus 2 sin x. Okay, f dash x is equal to 1 minus 2 cos x. We write the basic iteration formula, xn plus 1 is equal to xn minus fxn upon f dash xn. Correct? We put down the values. Xn remains xn minus, as per the function, it was x minus 2 sin x. So here it is xn minus 2 sin xn upon 1 minus 2 cos xn. On further calculation, what we get our result as xn plus 1 is equal to 2 into sin xn minus cos xn upon 1 minus cos nx. We will do further part in the later on videos. Thank you.